So if we want to rewrite this using partial fraction decomposition, then what we typically do is we look at the denominator and all the different factors that are in the denominator. There's an x minus 5, and a 4x minus 5. So our goal is to rewrite this so that it's an equivalent expression with those factors being independent. We're decomposing. Instead of having all the factors as one denominator, we're decomposing it into 3 separate rational expressions, where each of those unique factors are in the denominator. So we call the numbers that go up here the coefficients that we need to find. A, B, and C is what we call them. And so the way that we're going to be able to solve this is that if you were to multiply everything so that you could get your common denominators back again, you would have A times x minus 5 times 4x minus 5 in the numerator. And this numerator should equal this numerator if we were to get those common denominators back in place. So this is the equation that we're going to be solving for A, B, and C. And so B has an x minus 5 in the denominator. So if I was to multiply it by x and by 4x minus 5, and then C is multiplied by x and x minus 5, everything that's missing from the denominator. Okay, so A is multiplied by everything that's not in its denominator. B is multiplied by everything that's not in its denominator. And same thing with C. And so you're going to solve this by picking particular values of x that make the equation easy to solve for one of the letters. Okay, so looking at A, when I'm trying to solve A, what did I do here? This is supposed to be x minus 5. I wrote a 4. I don't know why. No? 4x. Okay, it's missing an x. Okay. So yeah, the way you're going to solve this is by using particular values of x that make the equation much simpler. I'm going to start with x equals 0 because I know x equals 0 gets rid of this entire term because 0 times anything is going to be 0. And it gets rid of this term. It leaves me with just one of those letters with the letter A. So if I was to plug in 0 everywhere, including on the left side, then I get A times 0 minus 5 times 4 times 0 minus 5. Then if you solve that equation, this is 0, 0, so we got 50 on the left side. And then you got A times negative 5 times negative 5. So A is going to be 25. That means, it's going to be 25 times A. If you solve for A, you should get A equals 2. So there, we found out one of them. We know that 2 is supposed to be in the numerator. And you repeat that process. Back this up. Found out what A is. Now I want to solve for B. It means I need to pick a particular value for x that makes everything disappear except for the B term. So this has x minus 5 and 4x minus 5. This has x and x minus 5. Look, both of these terms that I want to eliminate have x minus 5 multiplying. So I want to choose x equals 5 to make those terms completely disappear. So if I plug in x equals 5 over here, I'm going to get squared is 25. 25 times 5 is 125 plus 200 plus 50. And like x equals 5 makes this cancel out. X equals 5 makes this cancel out. So we just have this. So it's going to be 5 times 20 minus 5. That's 15 times. Doing the arithmetic a little quick here, you might want to pause and make sure you get the same thing I get. But I get 75 times b on the right side. And then if you solve that equation, on the left we have 125 plus 200 plus 50 divided by 75. I get b equals 5. So a equals 2, b equals 5, and then to solve for c, I'm going to plug in a value for x that makes only the c term remain. If you look at the other two terms, they both have 4x minus 5, so I'm going to plug in x equals 1.25, or 5/4 in other words, because 1.25 times 4 makes 5. 5 minus 5 makes 0. Makes this whole thing turn into 0. So if I plug in 1.25 into the left, I'm going to square it times 5. I'm going to copy that result to my clipboard, and then 40 times 1.25 that result, and then plus another 50. The left side is 107.8125. And on the right, if I plug in 1.25 in for x, the left side completely simplifies to be negative 4.6875c. So to solve for c, I just need to divide that from both sides. Oops, that's what I meant to do. So it looks like c is going to be negative 23. And now we're done. If you plug in 2 here, 5 here, and negative 23 in here, and if you graph this expression, it should be the same as this expression in Desmos, equivalent.